I'm going to cover the category 3.6, which is like the binary strings as a data type. So let's get started. In the 3.6, how many type of data types we have, which is like binary, Varbinary, and image data types. So let's see one by one each of them. We have the first category or the first type as binary. Binary is like fixed length binary data, which has like the byte size mentioned in the character as n, and the range starts from 1 to the 8000 characters. So we have defined it with the 50 characters. Okay, so we have declared a variable for the binary. We are storing a text into this basically a variable, but ideally the binary content itself represents the binary uh, data represented is like it can be saved in a file, it can be saved as a text, right? So it can be saved as a image file, right? It can be saved in a different file format. So all of those contents can be saved in this using this data type mainly. So that we are using it as a binary. So I'm just using for an example sake the simple text as an input to this variable, so that just by typecasting it like the converting the text in as a binary, I'm just converting the plain text into the binary so that it can be retrieved, and we can see like what it retrieves and what is the string within that. Then we may be converting back from the binary to the string to that. First we will see the binary, what the binary, like how this string is saved as a binary, that you will see here. Then we will check the data length in the byte size. Then we will check how this binary can again be converted back into the string, how it is like initially assigned to it, how it can be retrieved back once it is assigned to a binary variable. Means like saving into the binary variable from the string, saving into the binary, and then again converting back that binary into the string. Okay, so two-way process. So that is what we will see into this variable, and then we will check the length of that particular output from the binary, the characters that we fetch, right? That we will check the string length. Okay, so let us just run and see. So see, like there won't be any difference in the number of characters it may occupy. Why? Because the declaration wise binary is assigned as 50 characters, which ideally is a fixed length binary data, meaning it may not change even though if it is unused, unoccupied in the memory. So let's say you used only or you consumed only say like 10 characters out of 50 characters, then even then it will occupy the memory size as 50. For that reason you are seeing the byte size as 50. So binary, how this text is converted into the binary, that you can see it here. See, this much big string it creates in the form of binary from the text like this. Generally we may use this like we may use the composite key or unique com columns, or maybe like like a PII data, personally identifiable data, that if we want to maintain, right, we want to hide that from the external users, right? So in such kind of scenarios we may use this binary format so that the data doesn't appear to be visible to the end customer or to the any external entities, whoever may be having an access to this content. Or maybe if we are passing it to the lower environment from the production to the other environment, then also they may not be able to see the clear text data. Okay, so that is why the purpose of binary encryption, or kind of not encryption exactly we can say, but it's just like a conversion of the text in a way where it is not in the readable format. Okay, So it's the only way we have to convert it back into the characters, then only we may retrieve that text in the string format. Sometimes maybe if the string is very large, suppose say you assigned a very large string to the binary variable, so binary will save it in the format, but while it converting back may not always necessarily be the same. Sometimes it may change while converting it back into the original, because based on the typecasting again, see right now I am saying like 50 characters, I am assuming that 50 characters may retrieve this much text from the binary. But supposingly if the text is very wide, for which I do not have any clear idea how many characters it may retrieve, then I may not be able to define or assign a the size to it, right? So in such case you may lose the text, right? There are chances for that. So to do that, before that we are just checking the length to it, so that we can understand that how many characters, after we convert the binary back into the character, how many characters are used and how many characters it is occupying in the memory. So that it is 50 characters. This is basically a 50 character string, so it has occupied 50 bytes in the memory. Okay, now we will check on to the second type, which is Varbinary, which is variable length. Same thing, only just the variable length. The byte size in the same way and the range also remains same. So let's just run and see to the difference. See the difference here, the same text we have assigned to the previously to the nchar variable, or binary variable. The same way we are assigning it to the Varbinary. The same text is what we are assigning to it. Earlier it was showing 50 characters in the byte size and the string length was 50 characters. Now as it is not consuming the whole 50 characters, it is consuming only 38 characters and 12 characters is still left to be used. So it has excluded from the, or it has released that from the memory and occupied only 38 characters in the memory. That's why this byte size is okay. Clear? So let's just move on to the third type, which is this image now, which is very important, interesting, uh, and little bit not easy to be presented in the simplest manner how it can be represented in here in the variable. Because like see, if you understand, like the image cannot be easily assigned to a variable. Okay, we may have to save it somewhere, we may have to retrieve it from somewhere, and then we may have to extract it somewhere. Okay, we may need a storage, a physical storage we may need. Either it could be in the form of a table, either it could be in the form of a physical file, or it may need some location, remote location, FTP location, cloud location, any specific location, network share. Then only it can be saved somewhere or retrieved from somewhere. Okay, so for that reason, just understand image is a very different type of content, and when you want to use this type of data type for a column, or say like for a variable, then you need to retrieve the content, like here the content is of a variable length. Okay, and the range is very large in the byte size. Okay, this is the range to it, like starting from 0 through that. Important thing here is uh, just to present you how these images can be stored in a physical path or a particular path, or how it can be read from a particular path, and say like copied from a particular path and paste it to some location, or say like copying the same content to a different location. Like that is what the kind of example I have come up with, so that I can explain you the scenario and the usage of this data type. Now to do that, I needed to do couple of settings, is what I have mentioned here, not necessarily for you to understand at this level of beginning, but just as I use this example, so I need to put into this example, so I'm using it. What it does basically, it just does the configuration, right? See, SQL Server has all this configuration in the Object Explorer and couple other components. So what it does here, using the built-in SP configure, it just configures the server settings. Okay, what it sets is turns on the advanced option to configure the XP command shell. Now what is XP command shell? It's just like a command console, like what you see here is the command window, right? You are familiar with this command window. So that is what this command window command or command window is, the object itself, like the command window object is what we are enabling from this SSMS environment basically, or we may use that environment specific formula, or say like a statements we can run, okay, or say like a commands we can run from there. So here the argument 1 is given, like, so the advanced option is turned as 1, means like turned it on. Then second option is here to enable the commands. First thing to turn it on, and then second is to enable it, so that it can be used, in the subsequent code. Okay, so that is why this second SP, again the same SP configure, but just the option is changed. The actual command name or the tool name is what explained here, and then the value to it to make it enabled. Okay, and then again you press the reconfigure, so that it will set appropriately that settings into the tool, the server tool. Okay, it turns on the advanced option to configure OLE automation procedures. Now again the second kind of tool, or second kind of component, or the store procedure that we may have to use, or the setting we may need to do, is for the OLEDB, or for like OLE automation, object linking and embedding automation procedures is what we are using here. So SP configure, like show advanced options as 1, reconfigure is to reconfigure the same. Then we are using again the same procedure to set this procedure as 1 as a value for that, reconfiguring it. Okay, now we use this database now to retrieve this directory. Now say like if there is a file, let me show you one folder here. Okay, now this is a folder in which like we have stored the two files for an employee 1 and say like employee 2. Now there are two files for this employee is stored. Now if I have to read these two files and copy them into this output folder, how can I achieve that functionality is what I am trying to implement over here. Okay, now to read both of these files in a sequence, maybe this is like a 2, but it can be like number of files, number of image files you may have in a real-time environment. So how can you read those files and write them out to the particular folder? Okay, so that is what I am explaining over here in this example. So first of all, you may have to read that directory. Now which directory you may have to read? C is the physical path that I have given to it, and star means like any file starting with any number or any name but ending with the .jpg as an extension to that file, and read any content within that directory itself. Okay, now so we are declaring all this file names variable, this is like a table variable that we have defined. Okay, so that we are temporarily storing the employee file, the file name, or say like a file path, physically file name only we are saving into that. So we are inserting the file name into it. After executing this master command like the XP, this is like the like a store procedure that, or the command that we can run using the master database. Under the master database, this is the built-in view we can say, or like a command that we can run so that it can be passed. This command can be passed like the directory C images, and under that star.jpg. So whatever files that we may have under this directory, C images is the path, and underneath whatever the .jpg, how many whatever files there may be, all of those files will be read into this exact command, and then it will be inserted. All of those file names will be inserted into this table in this column called employee file. Now to display all of those file names, we have written this command or this statement. Okay, select star from this table name where employee file is not null. This is like an old construct. How this is like an option 1, how we can read the directory. There is an alternative command for the same activity. Let us just read through this first one, and then we will see the next one. Okay, now you see like both the file names has been read. So emp1_1.jpg and emp_2.jpg, both of the files have been read. Now after it is inserted into this table, we may be doing what? We may be reading that table for each of those files and then copying them into the target folder, which is this folder, which is the output folder. Currently there is no file into this, right, as we see. So we will be copying both of these files, both of these employee files, we will be copying it into the output folder. How we will do that? That we will see in this next command. Now the alternative way to retrieve the directory content is this. This was an older or the legacy way of reading the files, where we have to write down specifically this where condition, when employee file is not null. So if you see, by default it retrieves the null record along with that as a system bug, or what we can say. For that reason it is retrieving additional record which has no file to it. So to exclude that, I have to write this. Okay, so we will be writing it like this. Now in the latest system, now starting 2017 onwards, SQL Server 2017 onwards, there is a built-in dynamic management view. The view itself has been made up in the system, so that we can easily retrieve those files just by writing the single select statement, running that dynamic management view, right, and passing the path to it, and passing the extension, means like the expression, or say like a regular expression, right, like the star.jpg is kind of an expression. So that is what we are passing to it. All of this we will be passing in, and then we will be seeing to the content just by running the select star from this table name. Let's just see. Let's see, it's very easy. It has like many other commands. I mean, if you just want to understand, you can just run this as like select star from this table, and just run this single select line, and see how many different type of contents are like stored in this table. It stores the full file system path, where it is saved, parent directory to that, file name or the directory name. We are using currently for this purpose, we have used only this column. It could be this, it could be parent directory, the other level directory, read only, different type of columns, and purpose wise it is given, the byte size, everything it has given, right? So very useful and very interactive. So let us just roll back that change. File or directory name, which is what this column data represents, that we will be using in now. Afterwards, now we read all of these files, what we will be doing, we are checking the maximum value. We are checking the maximum value which is available into this table variable is what is the maximum value, which is second, which is the 2. 2 is what is saved in this variable. The maximum value in this table is 2, the ID column value, I mean. So if you want to see just like this table, okay, I'll show you this. Okay, So here you see like the ID, the maximum ID value is 2 only, right? So that is what is getting saved in this variable max value. By default we will be starting the counter from first record, meaning like how many files we want to traverse, right, from that directory is what we are assigning and defining here. The counter will start from the first record and it will go up to the last record, which is the max record, meaning starting from first till the second. That is how it will loop the files or from the directory content, and then retrieve the image data and save it to the file path. Okay, now variable query and then object initialization, all of this is what we have defined over here. Now I'll explain you one by one. Table we need to create now. Okay, now as we read all of this file into, or say like inserted all of these file names into a table, what we want to do is we want to uh, retrieve them and save it to this table. And in this table we are going to save the binary file or the image file content. The content of the file itself we are saving into this table. The previous file table we used just to save the file name, but here we are going to save the content itself, the image content itself we are saving into this. Okay, so that we have created the table and the column name and the type is image we have defined to that. Now here we are specifying the while construct to loop through each of the file or directory or the table to import or to the export. Import from where? Import from this table where we will be inserting this image content in the image format. Okay, that we will be inserting into this table and then we will be exporting it from that table. Okay, so for that reason we are looping through here. So first counter will start from the 1 and the max counter will go up to the second record as we saw earlier, right? So less than or equal to is an operator. It just tells the pointer in the system that start from this character, start from this number and go up to this number, which is less than or equal to. Whenever it becomes equal to this target, which is like 1, when 2 becomes 2 or 2 equals to 2, when that condition becomes true, it will stop this loop only. Okay, until then it will continue to loop through it. Now this statement is to read a source path. Now reading a source path means see images file path. Whatever we have saved, that path is what we are reading, and the file name we are retrieving from where? File name is what we are retrieving from the previously defined table. From there we are finding the file name, because see, one file, if you know that particular file name, then you can just mention that file name in the path directly. But say like if it is dynamically you have to retrieve say like 50 files, you may not be able to write it 50 files, right? So to minimize that effort, we have written this table and stored that table, and we are looping through each and every record of this table. See where condition is id is equal to variable id, means the counter. Okay, so each and every file of this table name, file name of this table, we will be assigning a path to this variable which will form the file path. Entire file path it will form and do the insert into this employee image table. So this is like a SQL statement, the open row set statement that we can say, which basically does the blob binary large object. Okay, object it just inserts into the target table. Okay, this is like a built-in command of the SQL server which can be used to read the file and write it to the target table. Okay, so we are storing that query into this variable and running that query using this system store procedure to execute this SQL statement. Okay, once it will execute this statement, it will insert the records or the file or the image will be inserted into the table, and then it will be read as a binary. Now image data that you see, how we declared is, image data we declared as var binary max. Max is again the same size. What was the size? 8000 character, right? Var binary, the maximum range is 8000. So whenever you see max, go to the range and then try to understand what would be the max size to that. So where were we? Yeah, so we just saw that like the image data. Now whatever is the particular file into this image table that we just inserted the record to, this image is inserted into this table. Now we are reading this table to export that data out into this target table, okay, target folder. So we are reading this file from this table. For the particular binary, we are storing that binary data, meaning the image data. We are converting image data into the binary in the var binary format and then storing it into this variable, okay, and then passing this var binary content directly into the target system. Here this is like a variable assignment only. This is again like to form the target file path. This is like we are forming the target file path. See, image output is the target file, and we using the source file name, we are just fetching the file name so that we can give the same name file in the output folder, okay. So the file name will not be changed in the target. Now this is the last and very most important part, to export the employee's image file from the table. Now we found everything we needed for the target, everything, the variable setup and the file path we have. Now what we need to do, we need to create an instance of an OLED object. How it can be done? That stream. So adodb.stream is what we need to use. There is a built-in store procedure for that. SPOA create means OLEDB or OLE object. For that purpose, this is the store procedure. This is the built-in store procedure argument that we need to pass, and then this is like an initialization of an object. Whenever there is an object, we need to initialize it. Without that, it may not be able to use it. This is like an output variable. For that reason, output is the parameter that is given to it. Now setting a property of an OLEDB object to a new value. Now as we just initialize this object, right, OLEDB object, OLE object, we initialize it. Now we are going to set the value to this initialized object for the type equal to 1. Then the third step we will be doing is, we are calling the method of an OLE object, which is like a OA method. SP underscore OA method is the store procedure, built-in store procedure, system procedure. Again the same argument that we will be passing. This is like a method to it. What we need to do, we need to open the file. We need to open which file? The file which is saved in this folder. It is opening this file, employee file, and then writing in where, like the target file path it has opened, right, and it is writing that binary, that var binary content what we saved into this var binary variable, is writing that file in the target initialize object. Where it will be saved to it, the content is written in the memory first, okay, so that it is writing that content in the memory using this procedure. Then the next statement will write or save that content to the physical path. Where it will save? It will save it to this path, variable file path, which is output, means this path. Here under this path it will write that file, and then close that file. After that file content is written to this target, then close that file. After save, close that file, okay, and then destroy that object, means release it from the memory, okay. Then continue until the last file is retrieved. So this is like a counter to that. So the counter started with 1 here, then 1 plus 1 will make it 2, so that this value is 2. Now it will go up to here, then check like 2 is less than or equal to 2, means it is equal to 2. So it will again match. For that reason again it will enter into this, it will come up to this point, and then again it will become 3. Then it will go here and check like 3 is less than or equal to 2. No, then it becomes false. In that case it may not continue and just comes out of it and then displays the subsequent select statement. Okay, so now let us run this entire express process that I just explained you in a very deep detail level. I know it is not that easy in the beginning level, but I had no other way of explaining this particular data type, so this one came to my mind to explain it in a better way, and the concept is very useful, so it will be useful to you like in a learning also. Okay, so let me run this. So see, like the source folder, wherever we have written the select statement, so select statement has it displayed that select statement data from here, that initial file that we displayed, like the file name wherever we save the first folder, the first table in which, that is what it is showing, and the second table it is showing is this, where from where like we are writing it in the directory. Oh. Okay. Now let's see into the target. This file or directory name is coming up here. Okay, so the second statement is here, then the first statement is this is the first statement result, and this is the second statement result. Now it should have or it should have written the file to this output folder as is how it was in the prior folder, how it is here, these two files, right? Like see, there are two files in the output folder that we can see, 1 and 2. So both the same files it has written from the source to the target. That is what the example here. That's it for the session. Happy learning. Thank you.